attention for just a moment? Just a couple of logistical things as we're getting started here. So we're going to do some warm-up problems, some practice. We're going to go through a bunch of this stuff today and then move on to new things building on this tomorrow. I do want to let you know that I have not forgotten about your tests and all of those assessments. My goal, my hope, my dream, except I think I'm going to make my dream a reality, is to get those back to you tomorrow. So I just want to let you know that that is what's happening. All right, let's take a look at this warm-up problem. So the very first thing that you do in this warm-up problem is what? What did you do first? Draw it out, right? It's kind of like your givens, except you're not listing your givens in a formal like list sort of way. You're listing them in a drawing sort of way. So we have to have a 3 meters west vector. So if I start from here, I'm going to go 3 meters west. So if you don't have this written out yet, write it out now. Okay, we're going to do a lot of these today, and the more you practice, the better you're going to do. And then the second one is 5 meters north. So where's that going to go? Where do I draw that vector? Where do I draw that arrow? What's that? Going up. Do I put it over here? No? There's a specific spot that I should put it. Where should I put it? Look at your notes from yesterday if you don't have them out yet, because you might need them in just a moment. Can you describe, using the vector anatomy that we talked about yesterday, where do I put this 5 meter north green vector? At the head of the other one, right? Remember, the end without the arrow is the tail, and the part with the arrow is the head. So we're going to pick that up, and we're going to move it over here, like so. So there's my 5 meters north. And then, so that is my givens. What's my unknown? What's it called? It has a magical name. Maybe not magical, but a specific name. The what's that? The resultant. The resultant, yeah. And friends, I haven't heard you speak yet. I don't know if you're you're not sure acoustically what's going to happen if you're sitting in your new seat. But I want you to know, I want you to look at your notes right now so that when I ask, you can tell me where the resultant is going to go. So if you need to refer to your notes, do that right now. Where is that resultant going to go? And then I'm going to ask you to say it all together. Are you ready? Anybody need to look at it again? Are you ready? Okay. So the resultant is going to go from where? From the tail of the first to the
head of the last.
Yes, I love it. Tail of the first to the head of the last. Something like this. Woo, that's supposed to be a straight line. That is my resultant. We can call that R. You can call that delta X if you want for a change in position. That's fine too. Doesn't matter to me. I need to know both the magnitude and the direction of that. Let's do magnitude first. How are you going to do it? Yeah, go for it.
The Pythagorean theorem.
You can use the Pythagorean theorem, right? You have a nice little right triangle here. So we will do 5 squared plus 3 squared equals R squared. Yeah? Are you guys looking at me like, yeah, this is so easy. Why are we spending all this time? Is that what's going on? Or, okay, yeah. I saw at least one person say yes to that. Yeah. Okay, what'd you get for R? Melissa, did you get a number?
Yeah,
5.8? 5.8 what? Meters. Bam. Am I done with the problem? I'm done with half of it. I found the magnitude. I need the direction. This is where we kind of paused yesterday. So I want to make sure that you're with me here. In order to know the direction, I need to know both the cardinal direction stuff, but I also need to know the what? The angle. Okay? So this is where we paused. If you don't have your equation sheet out right now, pull it out so that you can look at it with me. Okay? I'm going to look way up at the top here. I think I have it in here. I thought I did. Maybe I don't. That's okay. It's on there. I need to know this angle. So friends, a couple of pieces of information because you're going to do the next one by yourself. So I want to make sure that you understand this. When you're finding the angle is always, or I should say the vertex is always at the origin. Okay? So when we're finding the direction, we're going to write this down right now. Okay? To measure the angle, The vertex is at the origin, where you started the story. Okay? We remember that on a right triangle, you've got 3 pieces. So I'm going to draw this out right here. This can go in your notes if you want, or in your warm-up problem, whichever you prefer. It does not matter to me. I'm just copying down directly from the equation sheet that we have. I have the opposite. This is the angle theta, the hypotenuse, and the adjacent. Okay? And we are familiar, I think, maybe with the 3 trigonometric functions, yeah? Raise your hand for me if you've learned the word SOHCAHTOA before. Most of you, I see hands up. So I'm going to write it down. You write it down on your paper too. Write it down right now. So again, on your warm-up problem or on your notes, I don't care, but I want you to write it down. Even if you know it, you remember it, it jogs your memory. It's great to just write it down sometimes to keep it in your brain. This funny word, SOHCAHTOA, what does it mean? What does it stand for? Why do we have it? Do you know? Do you need a moment to talk to your table mates and get a good sense of that? Or no? Melissa, what does it mean?
Sine, cosine, and tangent.
Sine, cosine, and tangent. That's what the S, C, and T stand for, right? Yeah. You got sine of theta. Cos stands for cosine of theta. And you've got tangent of theta. So that's 3 of the 9 letters. What do the OA and the OA and the O and the Ka mean? What is that all about? Yeah? Okay, cool. I feel like you guys are looking at me like, oh my God, why are we wasting time on this? Is that how you're feeling? Yeah? Okay, because usually when I teach this, I have some people that are like, oh my gosh, I don't know what's going on. If you've got it, have you got the angle already? Yeah? Does anybody want me to go through the angle? Yeah? No? Having a hard time reading y'all. Sure, go through it. What are the 5 and the 3? What's the 5 up here? Is that the opposite, adjacent, or hypotenuse? The opposite? And the 3, tell me about the 3. The adjacent. So we got the opposite, we've got the adjacent. So which of my trig functions am I going to use? Tangent? So the tangent of theta is equal to the opposite, that's 5, divided by the adjacent, which is 3. How do I get theta all by itself then? What's that? Do the inverse. You do the opposite of tangent, right? You do tan inverse. So the tangent inverse of 5 over 3 will give you theta. Friends, I want every single person to plug this into your calculator. If you don't know how, I want you to raise your hand or ask the person next to you so you can get help with it. We'll meet up in just a moment with that angle found. All right? Go, go, go. Friends, I apologize. I did not intend to waste your time. I intended to make sure this made sense to you. If it's easy, then we'll move on. Let me have your attention up here because there's one more piece to it. So first of all, we had to find theta. What did you get for your theta value? 59 degrees? Does that match? Okay. So one thing you need to double check and make sure some of you in math are dealing with radians. If you're doing radians in math and you're using the same calculator in physics, you need to make sure that you move it back to degrees so you're getting good numbers, things that make sense to us. So we've got now that our resultant is 5.8 meters at 59 degrees. Does that tell you enough to be able to find her? Yeah. Oh, it's on freeze. Bam. There you go. Now you can see it. Thank you. Thanks for letting me know. Am I done? So if I give you a axis and I tell you that she's 5.8 meters away from her origin, then you've got a whole circle worth of places she could be, right? A distance of 5.8 meters away. And then I tell you at 59 degrees, 59 degrees where? Does that mean, there are lots of choices, right? Like this could be 59 degrees. Does that mean she's here? 59 degrees here? Do you see what I'm saying? We need just a little bit more information. So not only do we need the magnitude and the angle, but we need to tell the angle relative to what? So this is probably new for you. Okay? So I want to make sure you're with me here. So even if you got this trig stuff down, which is fantastic, by the way, I'm super excited for you. I want to make sure that this makes sense. You're going to take your pencil, you're going to use your pencil as a guide. Okay? So we're going to look at the triangle that we started with. The one of, what was her name? Agnes walking. Here she goes. Okay? You're going to put the eraser of your pencil at the origin, and you're going to point it in the direction of that first arrow. Got that? You do it too. Everybody does it. Okay? So the eraser's at the origin. The pencil's pointing in the direction of that first arrow. What direction am I pointing right now? West, right? I am going to turn 59 degrees, what? North. You with me there? From what? West. 59 degrees north from west. That's how we need to label it. 5.8 meters at 59 degrees north from west. Okay, sometimes you'll see it as north of west, but I think, especially when you're first learning it, that from is a really, really nice preposition to go there. Okay? How are we doing, team? We okay? Okay. I'm going to throw you into the next question. Here it comes. So this is the one that we looked at yesterday. This is the one that we started yesterday with George. He was walking, remember this? 4 meters north, 6 meters east, and 12 meters south. You all helped me to figure out that the length of the magnitude of his displacement was 10 meters. But we didn't get to this angle yet. But y'all know how to do it. So I'm going to give you just a couple moments, okay, to figure out that angle and also to tell me the direction, okay? So I'm going to give you a couple moments. If you're stuck, if you're not sure, raise your hand, talk to your table mates. We'll get it. Go, go, go. Here we go. What do we get for an angle, friends? So tan inverse of 8 over 6. Is that what you did? Oh, thanks. I just get excited. There you go. Now it's like I write really fast. It's magic, right? All right. What did you get for theta? What did you get for theta? Next, what did you guys get? 53. So we got 10 meters at 53 degrees. But 53 degrees where? We got to decide that, right? So you're going to line up your pencil and then turn it. So what do we get? South from east? Awesome. You guys are rocking this. Let me give you a harder one. I'm going to let you work on this one by yourself. Does that sound okay? Give it a shot. There you go. You do not have to turn it into meters. You can leave it all in kilometers. Yep, no reason to. So it seems like after drawing this picture, you've got two little triangles, right? The trouble with that, friends, let me explain it. The trouble with that is that I don't know where this splits the 3.1. I know that it's not in the middle because these aren't congruent triangles. Okay? Like if I was in geometry, I could write a bunch of things about having, similar triangles and blah, blah, but I don't want to have time to do that. No, not today. I want to make a nice right triangle. Okay? So the first thing I do is to write out all of my vectors. The second thing I do is to draw my resultant. And the third thing I do is to make one right triangle that fits the story. Okay? So the one right triangle that I could draw has one leg that goes like this and one leg that goes like this. Are you with me, friends? How long is this blue leg over here? 3.1 meters, right? How long is this green line here? 10.4 meters. Yeah. How are we doing? Is that okay? So there's often an interest in making two little triangles, but it's not going to get you anywhere. All you need to know is the length of this yellow. So to do that, just make one big right triangle, okay? And then you'll need to find an angle. This is the angle I would look at, because your angle always has to have a vertex at the origin. Okay? I'm gonna let you keep cruising. So it looked like a lot of people were kind of jiving with this, like this is making sense, right? So to find the length or the magnitude of your resultant, just use Pythagorean theorem. True? Easy peasy, we got this? Okay, so that means, so you did 10 squared or 10.4 squared plus 3.1 squared, and you square rooted that to find the resultant, and what did you get for the length? Oh, it's always frozen. Silly me. Sorry, somebody needs to remind me that every time. What'd you get, Andre?
Oh, I didn't do that for you.
Oh, okay. Did anybody get it? Bella, did you get it? What'd you get? Just for the length. So just the magnitude of that line. 10.8? You guys corroborate that? Agree? Yeah, 10.8? Awesome. Kilometers, right, actually? These are all supposed to be kilometers. I'm sorry, you guys. I'm just going too fast. Is everybody cool with that? Yeah? Okay. And then to find the angle, I heard somebody say, are we always going to use tangent? Until 3 minutes from now, yes. Yeah. That's a good face. In problems like this, when you're trying to find the angle that the resultant is at, you will always use tangent, right? It's going to be opposite over adjacent. So I have the tangent of 10.4, or excuse me, inverse tangent of 10.4 over 3.1. What do we get when we do that? 73.4. And what is the direction? We start facing south, and we turn to the west. So it would be west of, or west from south. West from south. Okay. Did you get the same answer back there? Claire, did you get the same thing? Nope, she says. Why not, Claire? Oh, so Claire's a rebel, right? Or just wanted to do it that way, and that's totally fine as well. So we talked about this earlier, which is why I asked her specifically. She drew this triangle. Okay? So basically, she just made the other part of the rectangle. Does it make sense that the length of that is going to be exactly the same? Yeah, because same Pythagorean theorem process. But the angle that you got was what? 16.7. Okay. Now, the interesting thing about 16.7 and 73.3, right, is what? They are complementary angles, right? So did she do it wrong? No. But when she writes it down, it's going to be 16.7 degrees south from west. You with me there? Is there one that's right and one that's wrong? No. There are two absolutely equally correct answers. Okay? You do have to make sure that your angle and your direction match. Because if you said 73.4 degrees south from west, that would be wrong. Okay? So you have to make sure that your angle and your direction match, but these are both absolutely fine for answers. How are we doing, friends? Doing okay? Can I throw one more thing at you? Sure, we got seven minutes? Plenty of time. Here comes the last one. Might need a new piece of paper. Maybe not. It depends on how much paper you have, I guess. Half a page? All right, here's Carl. Carl has a total displacement of 15.5 meters at 31.7 degrees north of east. It's a little bit of a different question, right? My question is, how far does he travel north and how far does he travel east? We're doing exactly the opposite thing that we did on the other problem. So you with me there? We're going to start by drawing a picture. So let's go ahead and do that. I'm going to draw it with you. Here it comes. So generally with these problems, I start by drawing my axis just so that I've got something to work from. And when I'm drawing my picture, I generally start from the angle because I need to know where that vector is going to point. So I need to go north of east, so I'm going to point east, and I'm going to turn north 31.7 degrees. Start east, turn north 31.7 degrees. And then I'll go ahead and draw my vector like that. So this is 15.5 meters long, okay, at an angle of 31.7 degrees. The question then says, how far does he travel north and how far does he travel east? So I'm going to go ahead and draw two vectors, one of which goes east and the other one goes north. To keep track of these, I usually write them as X and Y, just because it's a nice way to look at that. Okay. I'm going to keep walking through this for people that would like to see it, but if you know what to do and you want to just go with it, then you go. That's absolutely fine. Okay? The 15.5 is the hypotenuse of that triangle, right? Okay? If I'm looking for X is the adjacent side. So now I'm not going to use tangent anymore. You see what I'm doing here? Okay? So I've got the hypotenuse. I want to know the adjacent. Hypotenuse and adjacent, which trig function do I want? Cosine, right? So I'm going to say that the cosine of theta, I'm just reminding myself of what this is adjacent over hypotenuse, which means I could write this as the cosine of 31.7 degrees is equal to, the thing I don't know, my adjacent side, divided by 15.5 meters. Okay? To solve here, I don't need to do an inverse cosine. I just need to use cosine plain old. I'm going to multiply by 15.5 on both sides. So I've got 15.5 meters times the cosine of 31.7 degrees. What do I get for a value there? Somebody get a number? 13 point something? 13.17 meters. And I'm going to go ahead and write east here so I don't forget. We'll do a similar process for the y direction. In this case, we're talking about the opposite side. So I've got the hypotenuse and the opposite. Which trig function is that going to be? Sine. The sine of theta is opposite over hypotenuse. The sine of 31.7 is equal to the thing I don't know, my y, over 15.5. 15.5 meters times the sine of 31.7 has a value of something like, what, 8.15 or 8.14? Is that right? And that would be to the north. This process I want you to label this on your notes so that you know, okay? This process of taking one vector, one arrow that has magnitude and direction, and breaking it down into pieces is called finding the components of a vector. Okay? Finding the components of a vector. Your homework for tonight is 3 questions, 21, 24, and 25 on page 112. Those ones involve finding components of a vector. Okay? I will give you tests back tomorrow. I'm going to let you know that probably on Thursday, we will do a check-in for this standard. Okay? So kind of like we did yesterday with projectiles, we're going to do a check-in. These are going to be kind of quick standards here. So a check-in for this one on Thursday. Okay? Probably 2 problems, 1 of each kind. All right? Bell is going to ring in just a moment. Have an awesome Tuesday.
I remember different.
Did I miss number? Did I